Hello, everybody. Welcome to today's Lunch and Learn. My name is Brenda Petrella, and I am a safety consultant and project manager with Spotlight Solutions. And today I'm excited to share with you an overview of how to make your labs more sustainable. Back in the day, I was a research scientist before I got involved with biosafety and greening labs. And so I understand some of the challenges that scientists and safety officers and facility managers face when trying to balance the priorities of science and safety and incorporating sustainability. So I hope the information that I share today will help get you started with greening your lab. So the main outline for today, we're going to go over the four main goals of lab sustainability. We're going to discuss 5 key areas of sustainable lab practices. I'm going to give you some tips for getting started and some resources to share with you. So the four main goals of lab sustainability are to, of course, reduce the environmental impact of science, but it doesn't end there. Our hope is to also to be able to improve laboratory safety, because any changes that we make in the lab should be done in a safe way. And an extra bonus would be if it enhances research efficiency to make it better for the scientific process. And lastly, there are substantial institutional cost savings that can be realized through these practices. In fact, it's estimated that if all lab buildings in the US improve their energy efficiency by 20%, 40 trillion BTUs and $1 billion would be saved annually. So there's a great opportunity here. So the 5 key areas of lab sustainability that we'll be discussing today are energy consumption, waste reduction, chemical management, water conservation, and sustainable procurement. So after data centers, labs consume more energy per square foot than any other type of building. In fact, a lab consumes up to 10 times more energy than a commercial building of the same size due to the ventilation or HVAC requirements that are needed to provide a safe working environment. Labs also often have a lot of specialty equipment, such as chemical fume hoods, which also impact ventilation, which we'll discuss in a minute, and other energy-intensive lab equipment that runs 24/7. Although running it all the time isn't always necessary from a safety or a scientific standpoint. Lab ventilation through the HVAC system is by far the most energy-intensive aspects of these buildings, accounting for up to 75% of the energy consumption. So the reason why lab ventilation is so energy intensive is because that labs use 100% of outdoor air for the ventilation. So nothing is recirculated back as the return air. Therefore, the entire volume of air in a typical lab is exhausted from the building's HVAC system about every 5 to 8 minutes, requiring a tremendous amount of energy to resupply, heat, cool, humidify, dehumidify, filter, distribute, and exhaust this air around the clock. And typically, a lab's ventilation system is set to 10 air changes per hour. So this means fully replacing the indoor conditioned air 10 times per hour. And this happens often whether or not the lab is occupied or vacant, or if it even requires that level of exchange based on the safety requirements or the research that's being done there. So therefore, conducting a ventilation assessment and reviewing the safety and usage requirements is key to identify ways to significantly reduce any inefficient energy consumption that's happening. The Department of Energy National Research Laboratory, NREL, has an online HVAC assessment resource tool that's designed for facility managers, operations staff, and design engineers who want to better understand and improve their HVAC system efficiency. So I recommend checking it out. It provides extensive links with lots of information about different types of technology, energy efficient measures, trainings, lots of case studies. And another great resource from the DOE is the Smart Labs Accelerator Toolkit. And this is a dynamic repository for Smart Labs resources and best practices that will help you to comprehensively assess and correct any inefficiencies in your building's ventilation systems. One of the first labs or institutions to incorporate and participate in the Smart Labs Accelerator program was UC Irvine. And they, through extensive analysis and retrofitting, they were able to improve one of their campus buildings' energy efficiency by more than 60%, which is a tremendous savings. So chemical fume hoods impact lab ventilation as well. A single chemical fume hood can use as much as the same amount of energy as 3.5 households due to the large volume of air that must be moved through the fume hood that goes out through the ventilation system. And fume hoods can be characterized into two basic categories. There are constant air volume, or CAV, fume hoods versus variable air volume, or VAVs. Typically in older buildings and older fume hoods are of the constant air volume type, but VAVs are becoming more the norm because of their energy benefits. So the main difference is that in a CAV fume hood, the amount of air that's flowing through the fume hood is constant at all times, and you can't adjust that. Whereas in a VAV fume hood, the airflow can be adjusted according to the sash height. Therefore, keeping the sash closed when not in use results in significant energy savings by as much as 60% or more. Over the last 15 years or so, as Green Labs programs have become more adopted, countless academic and industry research institutions have employed what's called shut the sash programs, which is actually very hard for me to say, by educating and encouraging researchers to close the sash when a fume hood is not in use. And on average, this realizes an energy savings cost of about $1,500 to $3,000 per hood annually. As an example, Harvard's Shut the Sash program began about 10 years ago, and it has resulted in about $200,000 to $250,000 per year in saving, which is also reflected in a greenhouse gas emissions savings of 300 to 350 metric tons of carbon dioxide equivalent. There are a bunch of other energy consumers in the lab, including ultra-low temperature freezers. So a typical ultra-low temperature freezer, or -80, consumes about the same amount of energy as an average 2,000 square foot household every single day. Another example are large water baths. These can consume as much energy as a window air unit every hour. And large heat blocks can use as much energy as a 50-inch TV per hour. Because ultra-low temperature freezers are among the largest energy consumers in a lab aside from fume hoods, and they don't require the complicated engineering that's involved with the ventilation system, they are an easy target for scientists who want to green up labs. And about 10 years ago, a freezer challenge program was started where labs compete against each other for reducing the energy consumption of these ultra-low temperature freezers through various measures. This program continues to be widely successful, and it's supported by both My Green Lab and I2SL, which are two organizations that have a ton of resources available online. And I2SL is the International Institute for Sustainable Laboratories. This past year, the challenge had over 3,700 participants, which represented over 37,000 freezers in 36 countries. And since its inception in 2017, this program has saved over 108 million kilowatt hours. So although participating in the freezer challenge might be motivating and fun for your lab members, you don't actually have to participate in the program in order to take advantage of the benefits of doing the best practices that are listed here. So properly maintaining your freezer not only saves on energy, but it's also better for your freezer's health, and that can extend the lifetime of your freezer. Creating current freezer inventories increases work efficiency, and eliminating unneeded samples or reagents saves on space, which could possibly allow you to either retire a freezer, share freezer space with another lab, and or eliminate the need for future purchases of a freezer. Another tactic that people will use is to temperature tune your freezer from -80 or -86 to -70. This can reduce energy consumption by 30 to 40%. And back in the day, like in the 1980s, ultra-low temperature freezers were standardly set at -70. So it only became more recent that -80 and -86 became the the practice, and very few samples actually require that level of temperature in order to be stable. Um, there's a growing database of samples that have been confirmed to be safely stored at -70, including DNA, RNA, plasmids, lots of different reagents. And you can check out the Resource Center on the My Green Labs website for that list that's continually growing. Hundreds of academic and biotech labs have now temperature tuned their freezers to -70 with success. So the second category of lab sustainability that we'll discuss is waste reduction. So labs generate multiple waste streams, including hazardous and biohazardous waste, nitrile gloves, packaging materials, and mountains of single-use plastic, which provides sterility, convenience, and repeatability. And so in many ways, these single-use plastics feel like a non-negotiable aspect to the scientific process. But unfortunately, lab plastics can also be difficult to recycle. And the feasibility of recycling these plastics is often dependent on your location and region and what the local requirements are. And the economic and environmental impacts of manufacturing and then disposing these lab plastics is astronomical. It's estimated that the life sciences field alone generates 12 billion pounds of plastic waste each year from pipette tip boxes and media bottles and flasks, tissue culture plates, microtiter plates, film plastics, and so on. And this actually represents about 2% of the total global plastic waste. And to put that into a little perspective, according to Granova, which is a company that manufactures pipette tip and microplate washers for reuse, the environmental cost to manufacture one box of 96 pipette tips is equivalent to disposing of 15 plastic water bottles. So the best way to address lab waste is to avoid it altogether if you can, using better alternatives, eliminating it from any sort of process, or reducing the amount you need. There are several ways to start reducing lab waste, including going back to using glassware in place of single-use plastics for things like serological pipettes, bottles, petri dishes, and so forth. Additionally, there are a technology now, like the one I just mentioned, that exists to be able to decontaminate certain lab plastics, like pipette tips and microcell plates. And these plastics can be safely reused up to 10 times with no compromise to data integrity or experimental outcomes. And reusing lab plastics can actually reduce a consumable budget by 90%. Other options to cut down on lab waste include purchasing greener options, redesigning experiments to reduce the whole size and scope of the experiment, sharing lab supplies among other labs, including consumables and equipment, and also consolidating orders to save on packaging materials. So as I mentioned earlier, recycling lab waste can get a little tricky, and the options for recycling in your own laboratory are likely dictated by where your lab is located and the local regulations. So before you recycle lab materials in existing recycling waste bins, make sure that you check that that would be appropriate with your local waste hauler, your institutional safety officers, and facility managers. The materials that are listed on this slide here have been successfully recycled, but not all of them can be recycled universally. So that's why it's important to do some research first about the feasibility at your institution. And also, recycling should be sort of the last ditch effort before disposal. Better ways to reduce waste is just to eliminate it altogether. MilliporeSigma is in the process of collaborating with research labs to design a circular economy around recycled lab plastics. So they've developed a plastic waste assessment tool that can be used by an individual or an entire lab to measure the amount and types of plastics being used and how they're being disposed of. They are currently looking for labs in the US and in Europe to join their pilot program in conducting plastic waste assessments. And so reach out to them and contact them if you're interested in participating. Another way to reduce waste in labs is to look into supplier take back or trade in programs. This helps keeps material out of landfills or needing to be disposed of in other ways. So, one of the main reasons these organizations have developed these take back programs is because scientists have requested them, or they decide to take their business elsewhere. So I encourage you to inquire about programs like these for the suppliers that you use. So this is just a handful of examples. There are many more out there. But for example, Corning will take back their packaging products. Product packaging. Agilent has a trade in and buyback program for their instruments. Millipore accepts styrofoam coolers back. Biorad will trade in old equipment for new equipment. And then there are a bunch of organizations out there that will accept old equipment and refurbish them and resell them at a discount. So, the third category is chemical management. This is another key factor in sustainable lab practices. So, obviously, maintaining a complete chemical inventory is one important way to make sure that you don't order more than you need or that you're storing expired chemicals. And inventories allow you to share chemicals with other labs to avoid unnecessary or additional purchasing. Now, inventories are often required by institutional and local authorities. So you likely already have one and you can just use it to put it to use in this way. Another great way to manage chemicals from a sustainability standpoint is through the 12 principles of green chemistry listed here. Green chemistry is the design of chemical products and processes that reduce and or eliminate the use or generation of hazardous substances. And these 12 principles provide a framework for evaluating and minimizing the life cycle impacts of a chemical product or process. And thankfully, there are a lot of tools out there that can help you understand how to abide by these 12 principles. Here are some listed. So, the American Chemical Society has a solvent selection tool. This provides the ability to select solvents based on the principal component analysis of the solvent's physical properties. Millipore has a program that identifies opportunities for green chemistry substitutions for individual chemicals and different chemical processes. OSHA Transitioning to Safer Chemicals program has a methodology for identifying safer alternatives similar to the Millipore program. And Beyond Benign is focused on green chemistry for K through 12 education, but it's still a valuable resource for getting started in your lab. The next area of lab sustainability that we'll discuss is water conservation. So labs use up to 5 times the amount of water when compared to a typical commercial office building due to the water-intensive processes and equipment that's listed here, but also because there's often inappropriate use of high purity water, sort of unnecessarily, leaking and inefficient faucets, outdated processes like single pass cooling, and improper use of equipment, particularly autoclaves and glass washers. And water efficiency measures can offset rising water and sewer costs, which have increased at a rate of nearly 3 times that of inflation since 2001. So and that's actually much higher than that of other utilities, including electricity, natural gas, and waste disposal. So best not to ignore your water usage. Here are some solutions, no pun intended, for water conservation. So, as many of you may know, autoclaves are large water consumers. They use about 50 gallons of water per minute, 24 hours a day, 7 days a week, if they're not retrofitted with a water miser, which is basically like a solenoid valve that can reduce excess water use by as much as 99%. The downside to using these water misers is that when they fail open and often go undetected that they've failed. So to address this, the University of Georgia placed stickers on every campus autoclave to make sure that the users were aware of what it sounded like when a valve fails. And actually, within the first week, 2 units were identified as having failed valves, and this saved the institution $40,000 in annual water and sewer costs. So this is an example of how a little time investment, couple of stickers and an awareness campaign can have huge financial and environmental impacts. Other solutions for water conservation include using flow aerators, using waterless condensers for certain synthetic reactions, um, restricting the use of ultra pure water. Like I mentioned before, a lot of people, it's just easy to use the distilled water or whatever pure water you have in the lab rather than reusing water for washes or doing your final rinse really with just the ultra pure instead of all of the rinses with ultra pure. You can replace sink aspirators with mechanical vacuum pumps. And lastly, on a much larger scale, replacing single pass cooling systems with air cooled or recirculating systems have significant savings. And the last area that we'll discuss is sustainable procurement. So we've already discussed some of the ways in which improving purchasing choices by looking for greener alternatives is a good benefit. But how do you go about identifying what those are, and how do you take into account the entire life cycle of a product to really see its total environmental impact from its manufacturing to all the way through to its disposal, sort of the whole life cycle of a product? So, to help scientists identify which products have the least environmental impact, My Green Lab came up with what they call the ACT label. ACT stands for Accountability, Consistency, and Transparency. And this label was developed with the input from scientists, sustainability directors, procurement specialists, and manufacturers. So you can think of it kind of like a nutrition label for lab supplies and equipment. And it's been third party verified. So it's not through My Green Lab. There's a third party that verifies whether these products and equipment actually are, abiding by actually um, in line with what the label says. Um, and these the lower the number shows how much more sustainable it is. So the lower the number, the lower the environmental impact, the better the option to buy that product. Currently, there's a database of 1,000 products, thousands of products that have received the ACT label, and there are a number of manufacturers who now advertise the ACT label. So the more you look for it and ask for it or request it from the manufacturers, the more people will likely get on board with using something like this. You can search. I've put the link there for the database from My Green Lab if you want to see what products and equipment are available. So, in summary, here are some of the sustainable laboratory practices that we discussed today, such as closing fume hoods for variable volume fume hoods, freezer maintenance programs, reducing and reusing equipment and supplies, sharing supplies and equipment with other labs. And these are all examples of low hanging fruit with large energy and economic impacts that require very little upfront investment to get started. And so you can get started on these, implementing these in your labs today. Here are a bunch of key resources that are available for learning more about how to incorporate lab sustainable practices in your lab, including guidelines on developing a Green Labs program if you wanted to get multiple stakeholders at your institution involved, what that would entail. Um, all kinds of different assessment tools, extensive energy and water audit tools, benchmarking metrics, design ideas, case studies, and more. If you start to look into these resources, you'll see just how extensive the knowledge is out there. That's super helpful. So that is it. I'll take any questions if there are any. And if not, I just want to let you know that there is next month's Lunch and Learn is going to be all about our new equipment maintenance program from our Labs Ops division at Spotlight. And this includes freezer cleanouts. So this could be a good first step for introducing sustainable laboratory practices in your lab. So make sure you tune in next month for that. Just to see if we have any questions. I don't see any. So Thank you so much. Please reach out if you have any questions about lab sustainability or how Spotlight can assist you with that, or if you want access to any of the links that I shared today, I'd be happy to provide them. Here's our contact information on this slide, and hope you have a great day. Thank you so much.